So, having seen these three kinds of pumps, we would take a look at, now we will take a look at, now this we have seen that how the fluid is pressurized and pressurized fluid is generated. We have also seen the motor, which where the pressurized fluid can create a rotational motion. We will see another kind of actuator where it creates linear motion. We basically need these two kind of things. Sometimes we can transfer, I mean we can convert rotational motion into linear motion using things like lead screws, but we can also create direct linear motion using what are known as cylinders. Now, in between these two, that is where between the pump and the actuator, which can be a motor or which can be a cylinder, the fluid has to pass, and it has to pass in various ways. Pressure has to be controlled. So, various types of components have to be put in the path of its journey from the pump to the actuator. So, we need various kinds of, typically we need various kinds of valves for this, and one of the major category of valves are called directional valves, whose job it is to control the direction of the flow. So, which way it will move? Will it move from the that is the flow direction, because the flow direction is very much related to the direction of motion. Now, we want to create motion in various ways. Sometimes we want to create back and forth motion. So, if you want to create back and forth motion, then we have to continuously change the direction of flow automatically. So, for doing these, valves are required. So, we have various kinds of directional valves. We are going to look at these three. So, the first one is a one-way check valve, the second one is a two-way valve, and the third one is called a four-way valve. So, first the check valve. So, the check valve, what does it do? It will allow flow in one direction, but not the other direction, and it is. So, you see how it works, very simple. This is one of the constructions. There are various kinds of check valves. In fact, the mechanical design of hydraulic systems are very complicated. They require very precision manufacturing, and so there are various constructions possible, but we are going to see mainly schematics. So, this is one schematic where we use a ball type check valve. We can also use a poppet type check valve, various kinds. So, here what is happening is that this is a spring, and this is a ball. This is actually a ball, solid ball, maybe hollow also. So, what is happening is that if the flow is in this direction, then the ball will be pushed along the spring, and it will be the fluid will flow through like this through the spring. But when the flow will be in this direction, then the ball will be pushed in this direction, and it will come and settle and close this port. So, fluid cannot flow from this direction to this way, while it can flow freely through this. So, this is a symbol which shows that the flow direction is this, and this way it cannot pass. Having seen one way check valve, sometimes we need valves. We will demonstrate a case of pilot operated valves, because sometimes we also want that in the normal condition flow will be in this direction, but under certain special conditions the flow can be made in the reverse direction also. So, how do we ensure that? So, sometimes because remember that all this hydraulic equipment can actually be quite far away from the operators where the operator is working. They can be near the machine, etc. So, there are needs by which the operator from a relatively remote action it can operate, it can change the mode of working of the valve. So, for this reason pilot operated valves are used, whereby applying an external pressure possibly from a remote source, one can change the mode of operation of the valve. So, let us give an example. So, here you have a valve, you can see that this is the port, and this is my the member which controls the flow. This is a spring, and this is cylinder which separates these two. This is my pilot port and this is a drain port. You know, in these valves, remember that suppose a pump is trying to deliver fluid through a load and the load is moving. Now, suppose suddenly the load gets mechanically jammed, then what is going to happen? The pump is trying to drive fluid and the load is not moving. So, the fluid will immediately tend to get pressurized because it is incompressible, very high pressure will generate, and these very high pressures can actually be very detrimental. They can open, they can damage seals, fittings, they can create explosions, etc. So, therefore, pressure has also always to be in all this equipment. If the pressure suddenly tends to be very high because it is incompressible, so the pressure can very quickly rise to high values sometimes if there is jamming. So, therefore, there are always mechanisms such that such pressures has to be released. So, here is a this is that mechanism drain. So, now what is happening is that initially, so this is also a part and this is the port, this is the okay. So, normally what is happening is that this spring is pressing. So, this port is, these are actually solid parts, these are not, if you need to, this is the hollow part where the fluid exists, these are solid parts, metallic parts. So, normally what is happening is that this is the position of the valve, what is that called, stem, and the. So, now when the fluid is coming here, the fluid is pushing and this will come down if there is certain amount of pressure. So, there will be a certain amount of force on this and this spring force will be overcome and the fluid will flow out through this. This is the normal flow direction. On the other hand, if the pressure becomes too much here, then it may happen that the force is also here. So, the force on the, now because of the spring force, so if you see free body diagrams, the spring force is here and the pressure forces are here also on these. So, now if sometimes it may happen that the pressure here may move the spring up, in which case this will open, this will, suppose the fluid may pass out from in this way through the drain. In other cases, now suppose you apply a pilot pressure, then what will happen? Now that will come later. So, we can see that if we apply fluid flow here, the fluid will freely pass and in this direction. Now what happens? But it cannot pass in the other direction. Why it cannot pass in the other direction? Because if, let me change the color to mark the other direction. So, if the fluid now tries to enter this port here, then this is going to get pressed and this will close, So, fluid cannot pass in this direction, that is why it is a check valve. On the other hand, if in certain conditions we want that we want to convert this valve from we also want reverse flow. So, in that case we can apply pilot pressure here. If you apply pilot pressure, then this whole thing by pilot pressure will come down. So, this thing, now that I think we have a diagram, we have a separate diagram for the pilot pressure. So, we will show that. So, when we have pilot pressure, then this is the pilot port. So, you have pressure. So, this spring will be pressed and this will actually come out at the bottom, not exactly aligned, maybe somewhere over here. So, now the fluid, now this opening is opened, these openings are open. So, the fluid will pass and can flow through these. They can also, if it opens, they can also get drained. Okay. So, you see, so this is a typical pilot operated check valve. Similarly, there are situations where we need to change flow direction. So, typically we have 2-way and 4-way valves, and we must see. So, these are, this T means tank, this P means pump, and this A or B are the load ports, load or system ports. So, now you see that this valve has two positions. Okay. So, if in this position you see that the pump is actually connected to the port A. How it is going to come back to the tank is not through this, but through some other path which is not shown. So, you see that we draw it, there are two positions. So, we draw it by two boxes. Sometimes we may have three boxes in which there is a central position neutral. On one side we have pump and tank, on another side we have the load ports, and this arrow indicates that in each of these positions which port is connected to which port. So, in this position pump is connected to B, in this particular position actually this should have been A if you correspond to this, and this should have been actually. So, this means that this diagram actually corresponds to this particular box, where this is P, this is A, and this is tank is sealed. So, the tank is sealed and B is also sealed. So, these are sealed, as you can see. On the other hand, in the next position, see just the reverse. So, just the reverse, that is now it is in the right position. So, in the right position pump is connected to B and A and tank are sealed. So, you have the other box of that diagram. So, you see that a particular what have we achieved, that by moving the spool, just by moving the spool of the valve, you can connect either port A to pump or port B to pump. This is what you have achieved. And how do you move the spool? There are a variety of ways to move the spool. So, for example, the spool may be moved sometimes, when we draw the symbol, suppose we draw this symbol, then how do we move the spool? We may be moving the spool by a solenoid. Okay. So, we may be moving, if we write like this, this is a solenoid symbol. Sometimes we may be using, if these valves are big, it requires force to move the spool. So, the spool may be moved by either so this triangle means they are moved by hydraulics and pneumatics. If this is filled up, this is a hydraulically moved spool. So, sometimes these directional valves can be very large, and to move the spool itself you need another hydraulic force. So, this is a hydraulically moved spool, triangle filled. If the triangle is hollow, then it is a pneumatically filled, pneumatically operated valve. Sometimes, so these are very typical situations. Sometimes we may have this means that there is a spring. So, you only need to pull it in this direction, then return is by spring. Sometimes we may have an adjustable spring. So, there are all kinds of spool moving actuation mechanisms are there with this valves. You may also like to move it mechanically just by hand or by pushing something, pulling a lever. So, coming to then we come to 4-way valves. So, in 4-way valves it is exactly similar, only thing is that now in each position both A and B are connected to pump and tank. So, in this position pump is connected to B, tank is connected to A, while in this position pump is connected to A and tank is connected to B is connected to tank. So, you see that now by construction this is exactly similar. So, the same valve is becoming 2-way or 4-way basically depending on the geometry, how wide is this. It is the same type of figure, only thing is that previously we had this one as very wide. So, therefore, A was sealed. Now we have this one as a narrow one. So in this position, pump is connected to B and tank is connected to A. While on the, if you move it to the left, then pump is connected to A and tank is connected to B. So this is a 4-way valve. Now, as I said that you, in many cases you need to control the pressure or the flow through the valve. Sometimes velocity has to be controlled. If you are moving a very high load, you sometimes want that it moves at only at a certain speed. So for that you have to do flow control. If you want to, and pressure control is very much needed. So we have another, the other kinds of valves which are called pressure relief valves and flow control valves. So we will look at some of them. So this is a simple pressure release valve. So you see that this is the inlet, this is the inlet. So very simple, this is the drain, right. So actually this valve can be connected across a pipeline. If you connect it across a pipeline, this is your drain. So if the pressure here increases too much, then this particular poppet, this will push, this will be pushed up, and therefore the fluid will pass through the drain. So since the drain is at a low pressure, immediately pressure will fall. So high pressure cannot be created, and at what pressure this poppet will start moving and will open the line to the drain, that depends on the spring, and this pressure can be adjusted by tightening this screw. So if you tighten the screw, the spring can be preloaded to a value, and then at that adjusted value, if the pressure goes beyond that, then the fluid will be connected to drain. So this is shown by this symbol, that this is the relief direction, and this shows that there is an adjustable spring here. So this is a very simple pressure relief valve. Then we have a pilot operated relief valve. See, so that's more complex. So what we are doing is that this operation is interesting. So initially what happens is that by this spring action, you see here there is actually a small orifice which is not drawn in the diagram. The person who drew it missed it. So normally, because the fluid pressure here for steady pressure and the fluid pressure here are same. So therefore this is being pressed by this spring, and this is actually closed. This comes and sits on this. So the fluid is passing like this. Now if there is a very suddenly pressure rises, then what will happen is that because this is narrow orifice, so the pressure here and here will not be same. So suddenly if the pressure rises high here, this will be pushed up by that force, and naturally this opening will be opened and fluid will drain to tank. This is tank. So therefore sudden pressure rises can be controlled. Second thing is that if now the pressure, suppose the pressure rises slowly, then that phenomenon will not occur, but then at a certain value, suppose this is sealed, for example in this position it is connected to tank, but in this position, suppose this valve is in this position, therefore this is connected to the pump. This is the pump port. So therefore when it will be in this position, then this is connected to some pressure point. So suppose we might have sealed it. So then what happens is that as this pressure rises, this pressure will also keep rising, and they will balance each other. At a certain point of time, the pressure here will be too much for this needle valve to resist. So the needle valve will open, and then the fluid, this is actually a hollow, see the dotted lines. So there is a hollow opening through this. So then this fluid will flow through this and will go out to the tank. So even steady very high pressures cannot be sustained. So, lastly, we have a flow control valve. Now, what is happening here is that here we want to control flow. So, you see, okay, what we will do is we are actually running out of time. So, we will consider the flow control valve in the next lecture. So, in the next lesson we will actually begin with the flow control valve. So, I will skip this for the time being. This is cylinder. So, we can talk about the cylinder later. So, this from the last 3-4 slides we will take up in the next lecture. So, now let us come to the lesson review. So, what have we done today? So, today we have seen the basic hydraulic system principles, that some pressured fluid is created using a pump, and that fluid flows through that pressure is transmitted by taking the fluid through lines and is applied on the load to create various kinds of motion. And we see that it is possible to amplify force, but at the same time energy is conserved. So, therefore, the velocity that we can create gets limited by the flow rate that can be delivered by the pump at that pressure. We have also seen that for making an effective system, we need to have various kinds of components. We need the fluid, we need the lines, we need the sealings. Of course, we need pumps and the actuators, the motor. We also need to control the flow of the fluid. We need various kinds of valves, and among the valves there are some valves which control the direction of flow, and there are some valves which control the pressure and the flow. So, we will continue with this. We have seen pumps and motors, and we have seen part of the valves, some bits are left, and finally, we will see the cylinders in the next lecture. So, you may ponder what are the main advantages of hydraulics over electric systems. There are some advantages I have already told. The major advantage of hydraulic systems is that they can handle much more power at using much more low sizes. Therefore, they are of prime importance and used in aerospace. We will discuss this in the next lesson. We have you can identify the major components of a hydraulic system if you want to build one, and 3 major types of pumps, we have discussed it, and what are the different ways in which a directional valve may be operated. So, there are various types of directional valves, 1-way, 2-way, 4-way. So, that is all for today. Thank you very much. We will continue with this in the next lesson.